Hi everyone, it's great to be back in Brno. Did I say it right? I rolled the R correctly? Because I have a hard time. I'm living in Austria right now. I live in a town called Tulln. And in German it's called Brunn. Brno is. It's a little fun fact if you didn't know that. Timer. Do I want to do a stopwatch? Probably, right? That sounds like a good idea. Stopwatch. There we go. So we officially started. So I have been freelancing for, I don't know, 16 years, doing a lot of different technologies. For the last 6 years, I've been doing mostly, maybe almost 100% Elixir. If anyone afterwards has any questions about Elixir, come to me. I haven't written Go in a while, but I really enjoyed writing it. And I think the code examples and everything here is pretty universal. And I've been working since the agent boom now. I've been working a lot on kind of more side projects, and I run, and I've been kind of trying to make running related fun side projects. So what we're going to do here is kind of like a fake scenario of something that could have happened with one of my applications that I run, and how we kind of go through the process of making it more visible. So let's say I received this email that's like, hey, I'm running, I uploaded my run, but I didn't see any type of new zone being loaded. What's going on? This happened to my friend. Other times it hasn't happened. What's going on? And I get this email and I'm like, I need to fix this. So the app that we're talking about is an app called Encroach. It is an application where you can kind of go in and you sync your runs with Strava, and you gain grids, little hexagons inside of your city, and then if someone else then later runs in that area, they claim that grid, and at the end of the month, whoever has the most grids is like the mayor or whatever. In reality, it looks like this. This is Tulln, where I live. I've been around Tulln a bit. I was injured recently, so I haven't been running very much. I planned on going on a run here so I could show at least a couple of hexagons in Brno, but unfortunately I haven't. What we have here, I've created a demo app where at the end of the talk there will also be code that you can go to, download. It shows how to connect to all of these. There's a Docker Compose file that has all of the services that go along with it, the Grafana, the OpenObserve, all of those things, and how to connect it to a Go application. This is the app that you get. It's not pretty, but it shows what's going on in context of the talk. Where were we? We were here. Exactly. So this is the problem. His grids aren't showing up. This demo app is using just some basic, nothing really fancy at all, just some basic Go libraries, web server, Postgres, Redis, and some kind of connectors that we'll look at in a little bit. There's some grid cell math that goes on. So let's see what is happening with Marcus and his missing grids. So first of all, we're going to go into this application. We're going to start the Docker container stuff, and then we go broken, which is a really good name for this situation here. We can go into the application itself. That is the wrong page. That is a little foreshadowing. And then we can add fake runs to it. And we're adding runs. I'm Priya now. Why don't I be Marcus, just for funsies? And you can see that there's no grids showing up here. Like, what's going on? I can look here. I see the log output. Is this big enough? Good. And you can see that there's nothing weird. Like, everything is info messages. We get the run IDs. We get the grid information. Everything should be working according to what I'm seeing here. So everything's good. We can grep through it if we want to. It doesn't matter. We don't see any problems. And the problem here is that the system is telling us that everything is okay. It's saying, hey, look, everything is at 200. We're all good. But my users are telling me that something is wrong. And so there's some sort of a mismatch in knowledge here. And just because there are no errors, it doesn't mean that you're good to go. All of these things should be going well, but there's obviously a bug, and there's some important things that I don't know, like how long has this been going on? Is it even really going on? And who is it actually affecting? Is it just Marcus that's getting these problems, or are all of the users getting this? And also, like in the end, after I fix it, did that fix actually really fix anything? And the question here to ask isn't like, did the tiles get added? It's on the user side, are they getting what they need to get? And so the next part of the talk is kind of going step by step through kind of how I would hit this problem if I came from nothing. First, we're going to talk a bit about metrics. Metrics are like just numbers about stuff over time. So you have sums, you have averages, just information about things that are happening in your application over some sort of a time. Yeah. And I'm going to be talking more specifically in this talk about Prometheus. It has kind of a different model. I'm kind of curious. I don't want to know, is everyone familiar with Prometheus? Is everyone using it? Who's using it? That's fun. Yeah, so I don't really have to go into too much detail, but normally when you've done analytics stuff before, you're generally pushing to an API or logging straight out. With Prometheus, instead, the model is kind of turned on its head, and every n seconds, like every 15 seconds, it pulls your application. So you have to make that data available for Prometheus before, and you expose it via a metrics route, and yeah, Prometheus will scrape your information. You get time series, so instead of writing into like an InfluxDB or a timescale, the time series is the timestamps happen when the scrapes your application, which when you're using tools to look at it, for me at first it was a bit confusing that kind of all of the timepieces happened in 15-second increments instead of being like looking through the history of time and knowing more about like when exactly something happened. So it looks, as most of you know, a lot like this, where you have this kind of text page that you make available for Prometheus to scrape in your application. It has just a metric name and a bunch of labels possibly, and then some sort of a measurement, some sort of a number. And then on the right here, you can see that you can, in the Prometheus config, you give it a name. You can have multiple things that it's scraping. It scrapes itself as well, and the scrape interval, and then where it should scrape. Yeah, so one way that this turns kind of this whole metrics thing on its head is that you have to decide at write time what you're tracking, not at read time. So you can't, for example, have a bunch of things that you just crap into InfluxDB, and then at some point you go into Grafana or some kind of a tool and say, oh, I want to know how the averages of these things are interesting. You just have a bunch of data that you can read from. Instead, you have to upfront decide what is actually interesting for me. I like this constraint because it makes it so I have to be more thoughtful about my metrics. But I can't do things, I don't know about a specific user. I know about the behavior of many users. I don't know about a specific run or a tile. It's all an aggregate to start with, a count or some other types of things. And I'll go into like the first, kind of the three main ones that I use. What is the fourth one? Like I don't even remember what the name of there's a summary example. And a summary is a type of histogram. Who said summary? Sorry to put you on the spot. Was it you? Yeah. What is a summary? I don't use it. Okay. Like it's a type of histogram. So you have counters, and the deal with a counter is a counter can only go up. And that has some sorts of, the way that Prometheus generally works is instead of having to store something into a database locally, you store it in memory, which makes it so you don't have to do a lot of crazy stuff around it. It's just really stored in memory. In Elixir, it's actually stored in an actor, so you're just like sending a message to an actor. I'm pretty sure the way that it works in Go is there's some sort of a thing listening to on a Go func that is collecting out of a channel. So it's completely separate. The problem is that when you restart your application, that memory is gone, and you have to start again from nothing. And so your counter's back at 0 again. So for things about increases over time, if you have a query about increases or rates or things over time that take a counter into account, it has to be smart about knowing that a counter can go up to 1,000 and then down to 0. And when it goes to 1, it's 1001 and not 1 again. And with counters, with increase and rate, I think maybe those are the only functions. There might be a couple of other ones that are smart about counters and can do this math. They know that if something went lower than it was before, then that was it starting over again, and I will start the count at that spot again. You also have gauges, and gauges are things that can go up and down. So yeah, and then you have histograms, which are buckets. So for example, you can't do, as I said in the last slide, you can't do this idea of, every time I have a web request, I save the time that it took, and then in the end, I find the average time of web requests, because I actually don't know anything about individual web requests anymore. I can't say web request, I'm saying for some reason. So what you do is you create these buckets that a web request took 300 milliseconds. That goes in the greater than 200 milliseconds bucket. And then later you can make percentile, you can make different types of graphs, alerts, and things like that based on, oh, if 99% of the requests were longer than 1 second, I know that there's an issue. So it's kind of a way around that situation. You can see here also this LE 0.1, that's a label, and LE in the case of the buckets means less than or equal to, and you always have this less than or equal to infinity that's on the end that grabs everything. Yeah, so Prometheus just works. It can consume a lot of data. You don't have to worry about dealing with errors on your side, because it just, like, if you can't connect to Datadog or something, you have to handle that. Yeah, the downsides are that you have to plan ahead, you have to know exactly what you want to aggregate and things like that. So to add it to your Go application, you can just grab this client Golang. You can create a counter or a gauge like this, or a histogram is very similar. You give it a name, that name shows up. That's the name of your metric when you're looking for it in Grafana or anywhere. It also shows up on your page. We're going to look real quick here, just at, I'm holding lots of things, what our metrics page looks like. You can see here, these are some labels here. You can then filter on these labels using PromQL, which is a fun new DSL you get to learn when you're running this. It's one of the things I think that I still look up the documentation the most for, because I see some nods like it's pretty interesting to use. And then you have things here where it's not a histogram, but you still have this total code 22 or code 200 handlers. And then you can say, I only care about if 500 responses are more than 10 for this amount of time. You can aggregate on those types of things. But this is what your metrics page will look like, and it's what Prometheus understands. I keep forgetting where I am. I don't usually do presentations from the browser, so if I'm a little bit slow with certain things. And then if you want to use this metric, you can, there's this increment here, and you can, here is the gauge. You set it to something. Histograms are similar. Yeah, so it's pretty straightforward. And then when you start your application, whatever framework you're using, or if there's a handler func that you're using, you just use the middleware, and then for your metrics endpoint, you need to use this prom HTTP handler, which gives you the page that we just looked at a second ago. So what am I showing now? So now we're going to go to demo metrics, and we're going to hit the thingy, and we're going to submit some more runs. There's some runs. We've got a run. Marcus loves to run. We go to you. That's also something we don't want to see yet. We go to the dashboard. Also, with the Prometheus is running every 15 seconds. This will take a second to load. With the demo code, there's also the files that will automatically create these Grafana dashboards if you want to play around with them. We can look here. We don't have any errors. Our request latency is looking pretty good. Our request rate is fine. And what else do we got going on? Oh, that's interesting. Our cache hit rate is 100%. Maybe that's something we need to be considering. The runs processed, yeah. So anyway, we have some basic metrics about the things. This is every 15 seconds being scraped by Prometheus in the background. Fun times. I'm in the right place. So when we look at it, our requests, errors, and duration look fantastic. It doesn't look like we have an error, but we still need to figure out what's going on. It seems like something's going on. So one thing that we did notice is that our tile cache hit rate was around 100%. In the fake world for 18 hours. I didn't want to spend the time to make the demo really that intense, so pretend it's been 18 hours. And we now know kind of what's weird, but we don't know exactly where in the code base that weirdness is coming from. We know the cache is always valid, but we don't know kind of where that's happening. And where we can figure that out, actually I'm taking another little tangent. When I'm thinking about this information, when I'm creating a metric, I'm also thinking about, are there situations where this metric looks a certain way for some kind of a time span? Is that worth notifying myself or the team if we should do something, if there's something to act on? And in that case, I will create an alert. Otherwise, I will just make that metric available somewhere and I'll check it a couple times a week. But in this case, we can think, hey, let's say our cache hit rate is important to us. We can create an alert on that. In Grafana, we have alerts. We have these ideas of contact points, notification policies. Contact points are like email addresses if we're going to contact through Slack or email or SMS or whatever. Notification policies are kind of role-based, who is in the group for those contacts. And then alert rules, you can tag them. So also the notification policies can only certain alerts, certain groups of people. You can be pretty complex if you want to be. And we can go to our alert. We have one already created. We have a tile cache not refreshing one. And all you create, is that legible? It's a little bit small in the back. You create a PromQL query, and you give it kind of a threshold. And then you give it this idea of a pending period. So this will, right now, we're pending. That means that this alert is being triggered. We do have a zero tile misses and greater than 1 or greater than 0 cache hits in the last 5 minutes. So we're in pending status. If we stay in pending status, so every time this checks, if we stay in pending status for an hour, then this alert will be triggered and we will receive whatever the message that we're supposed to receive. Yeah. I think that is all that I want to talk about here. Here is one of the labels. So severity warning, you can say only severity danger error is the situation where I receive actual alerts from this. That way I don't get woken up for something that's not very important. That got way smaller. There, where are we? There maybe? Okay. I've had this clicker for maybe 12 years or something like that. And the plastic has started to do that weird, gross, rubbery thing that does. So it's very grippy. It's that fake sticky. And I've loaned it to people before and been like, you want to use it? I'm like, I'm warning you, it's very gross. And the comment always when they come back with it, they're like, it was very gross. And I'm like, I warned you that it's very gross. But yeah, it's kind of an experience every time I pick up this clicker. This is how they should look a little bit. And this is how, if you can see the difference in the back. So the next step is we will talk about traces a bit. Instead of just knowing what happens in one request or an aggregation of requests, with traces you can actually look at what's happening step by step in your code, what kind of values exist in a certain context, and like the timing of things. So we can now look per request kind of what is interesting. And we're going to be using OpenTelemetry and OpenObserve. I've used Jaeger for similar demos in the past, but I don't know if like the color scheme is weird and I can't see if it's in light mode. I can't see stuff when I'm trying to show people stuff. Jaeger's written in Go. It's a pretty cool project. It was one of the first of these that I ever heard about. It's also open source. You can run it on your own servers. It does very many of the same things that OpenObserve does, which is also open source, but has a weird licensing sort of situation. But yeah, so what you do is you connect to an OpenTelemetry collector, and that's just a database. Like Prometheus is a database. The OpenTelemetry collectors are a database. With Grafana, that team, a Go shop, they do Tempo is their collector that then works maybe better or the same with Grafana. They also have Loki, which is their logging aggregation system. But anyway, you're just essentially writing to this collector. You can write to Datadog, AppSignal. They all have their own OpenTelemetry collectors that you write to. You have to give it a host and a port and a path maybe. And then you just create a tracker. You create spans. And your spans are essentially the context of where this trace is going. You get a span ID. So one thing that's really cool, maybe I'll talk about it in a second when you have more context. But so you'll create this, you start the span. The span is where you start with collecting the path through your code. And you can set attributes, which is metadata on this span that is if you have like files that you're working with, or in our case, we care about cache hits and cache age hours. You can add that and those will show up then in that part of the span, in that part of the trace. I'm probably using these two words interchangeably and I shouldn't be. So yeah, we can go to the demo again, and we are doing traces now. So we are going to you. You're still not working. Let's go to demo runner again for some orange. Demo runner. Priya. Marcus. Yeah, good times. They're in the list. If I reload the page, they're here. And then we can go to OpenObserve, which is also running locally. Let's see if I can get this to work the way that I want it to. Good. And you can see here we're in the traces column. We have a bunch of these different operations that are running. And we can look through and see, for example, on tiles cache get, we have the whole path going through from where the span is opened to through the things. We have cache hit is true here, and then cache tile get, tile cache get, whatever, is here with some more metadata added to it. You can see the time that it took. One thing that's really nice, I don't know if you're familiar with flame graphs. Flame graphs are pretty cool. You can see kind of the timing of all of the parts of all the functions that are called. It's a good time. And you can see sometimes like you will find, oh, why did this one algorithm take so much time and these other algorithms were fine? You can find them in your flame graph very easily. Normally they're pretty colors. I don't know, maybe everything's just so fast in Go that it stays all blue. Is there anything else that I wanted to show here? I don't think so. Yeah, but anyway, this is OpenObserve. That's a thing. And we go to this. Is there anything else? I guess maybe I'm still supposed to be figuring out what's going on, but I think everyone knows that there's something going on with caching. So this is our pretend world again, 47 hours. Whoa, it's been 47 hours and there hasn't been a single request to the database. It's all been cached. Woo, crazy. What could be going on? And we can also see that there's no build from DB span. We saw this other DB situation here, DB insert, but we didn't see any kind of a DB get. Yes. So what could be going on? And Redis, like we're never reading. I'm saying the same thing over and over again. And so the system is actually working. We are caching. We're getting stuff from the cache, but the cache seems to be very, very happy and hungry. And yeah, that's the situation. So the next way to figure out exactly what is going on is to kind of use structured logging instead of the logging that we have been using, which looks a lot like this. And instead of grepping and going through our log files, we can push stuff out in JSON, have it consumed in some sort of kind of a collector, and then be able to not only just have that data, that log be very searchable, but also be able to create alerts and things based on our logs and not just on our metrics. To do that, we just have to get slog, which has been available for a while. Yeah. And then we add a new handler in between. Do you call these middleware? What would you call this? A strategy? Anyone? I usually have like candy and stuff to give away, but I think you're gonna, nobody wants to, no, okay, whatever. It's a thing. It's a handler. And yeah, then you can set the default logger, and then when you log out, you give it some of this, these cache age, the things that are going to show up in your logs. And then we're going to look at structured logs. How do those look? You are called something weird. What are you called? You're called full. I knew it was called something weird, but not what it was called. Oh, look already, we see something. It's amazing. And then we can go back to our application, which is here. We can claim some more stuff. And Marcus is still not very happy. He keeps running and keeps adding things. And we see that he's adding things here, but yeah, we don't know what's going on still. And then we can go to OpenObserve and go to logs, and we have to pick the data stream, which isn't here, because do I need to do this? And go to the data stream. We can run a basic query. We have all of our logs here. They're split up into these queryable things. You can do something like what? Body. You can go to SQL mode, for example, and have your screen be weird. And you can say where message body, I like percent tiles percent. Does this work? Does anyone know if this is going to work? I think it worked. It didn't work. This should work. So when you do it, it will work. Whatever. Cool. So that's fun. But you can query through your logs. There's probably some kind of a weird query language that they have. I've used the SQL before. It works really well, except for when I'm doing a demo. What's up? Single quotes? It's probably single quotes. But one thing also that's cool is you can go in and go here, and then you can view the logs. And I think it's still mad at me from before. This is where everyone starts leaving. This is really, I've done this a lot, and this is the first time that it was weird. Oh, I know what's wrong now. Now it's still in SQL mode. You'll know how to use this really well once just watching me screw up the whole time. Yeah, and these are related then to that type of, that where is it? I can go here, and then I can go to view logs. And one of these takes me directly to the actual trace. In this case, it didn't. It generally, here, can I zoom out? Nope. It normally will set also here where trace ID is this, and then you can just see the logs for that. You'll figure it out. Yeah. So yeah, fun times with structured logging. This is the clean one, not the gross sticky one. And yeah, so in our case, what we should have seen is that we had the cache age hours was way too long the whole time. So we're actually saving the things, but the cache is never invalidated. We need to then go in and just, when we create a new thing, invalidate the cache. One easy line of code. Fantastic. And now I'm doing everything. I don't want to do this demo. I'm not doing this demo. So the way that this works, like what we could do in the future is we get the message from Marcus. We can look in the logs. We see nothing useful. We go on then to our metrics. We can see this. We move to our traces. We move to our structured logs. And throughout the day, we figure out what the cause is. The problem is that we didn't have this set up in the first place. So we're going to make that never happen again and decide on kind of these different types of error, or these alerts that we want to do. So it's good whenever I create metrics, I try and think, is this a metric that I can act on? If it is, maybe there's an alert that's related to it that I can create. And these are some of the things that I could possibly create before. These would not have caught the problem that we had. And so instead of watching just for errors happening, we can think about possible things that we've seen that have been weird, or think of what could possibly happen, what could go wrong that would show up in our system that's strange, and create alerts and metrics around those. In our example, we can do the tile is not refreshing, the cache is stale, these types of things. We can add them to our alerts.yaml. And in this world, we would have found the error in the middle of the night instead of in the morning, later that day. Crazy stuff. And another question is like, is something alert worthy? Like, is something, thinking about the severity, like what I was saying earlier, like, is this worth alerting about? Or is this just something that I should put in a dashboard? And just some things to think about is, just because there's no errors in the system, I've said this over and over again, doesn't mean that there's no problems in your application. Caching is a hard problem, as people generally are aware of. And yeah, track as much stuff, sometimes track as much stuff up front as possible. Find some things, find some holes in your logging, your tracking. And this is something that we've been hit by with Prometheus. I think it's a hidden problem sometimes that people have in things like Influx, where you don't want to put the labels that you put into Prometheus exponentially grow. So when you're thinking about using a label, you want to think of it as like an enum. So if you have a data centers, for example, maybe you have a handful of them. That would be possibly something that you might want to label and aggregate on. Maybe later I want to be like, things are slow in this data center. But using IDs, like there's one project that I was working on that they were using resource IDs for some sort of electronic equipment. And that was one of the labels they were using. We had an issue that like Prometheus is missing scrapes. What's going on? And I went to load the metrics page, and it took like 10 or 15 seconds to load the metrics page, because there were, I think, hundreds of thousands of metrics on that single page that were being scraped every 15 seconds. So every time, so it says this, it's pretty dark, but the way that it works, the math is that for every label, the possible numbers, the possible variations of that label times the possible variations of the next label times the next one will be the lines that show up for that metric inside of your Prometheus metrics page. So if you have 10,000 runners, 10,000 resources, then you end up with like exponentially more of these things that are, and so like, it's also the situation with influx. You don't want to store IDs in tags, but I think that much further down the road, you find the pain from that, and it's just not a very good idea. They warn you against it, but people, I can tell you from experience on a project that I'm working on, that until it's a pain, people don't really want to do anything about it. Yep, so each of the different steps gave us different information. It's good to have kind of the 3 pillars. And I would recommend that if you don't have any of this stuff, like start setting it up. You don't need it all at once. Maybe open a Datadog account, or open what is it called again? I don't even know what I'm talking about in my talk. So create one of these, like start the service and then maybe add to one of your projects some of this logging, add to another project some of this, and then maybe add an alert here and there. You don't have to do it all at once is essentially what I'm saying. And this time, we don't get the email. We've already fixed the problem in the middle of the night. Hopefully maybe in the morning before Marcus woke up. And like, this is kind of something that I hold in my life through lots of different things. Like, try to be good to your future self, because I'm a hardcore procrastinator and I'm very horrible to my future self. But I've really been pushing more of this like in my mind, and it's been working. I've been better and better about these types of things, but it's also with observability. Like, you don't want to get that alert at 3 in the morning. Yeah, so again, the slides is just an HTML file, and the demo app, which has all of the connections, the Docker Compose file, so you can run all this stuff locally, see how it works together, is all available at this repo. And I don't know how much time there is left for anything. Thank you.